Hi, Dr. Cook here. We've got a short video to give you some examples about stability. All right, first I want to start with a review of some of the terminology that we've done in the past. So I've got some of the variables up here to remind you what they are. And as we have our projectile moving in space, our coordinate system is fixed to the projectile with the x-axis pointing down the nose. All right, that's the coordinate system local to the projectile, not the Earth. All right, and our yaw, pitch, and roll are shown on here with the arrows of which direction is the positive rotational direction for this, okay? Now, of note, when we talk about total yaw, which is a lot of what we've been using up till now, we use the alpha sub t for total yaw, but I want to remind everyone that the alpha by itself is actually a pitch angle. All right, around that z-axis, and beta is the yaw angle when we separate those two. So even though total yaw is alpha t, yaw by itself is not alpha, it is beta. All right, so let's talk about gyroscopically unstable. All right, so let's say I've got a gyroscopically unstable projectile. It's flying downrange. We are looking from the tail end, looking downrange, all right, is what this crosshair is. And that little red dot is where is our nose pointed, right now in time, and how is it going to move, okay? So if we are gyroscopically unstable, we're going to have some spinning, and that spin is going to grow, all right, because we're unstable. It's going to just keep getting larger and larger until we hit a point of tumbling out of control. Once we hit a high enough angle, then pressure forces from the air acting against the larger presented surface area are going to tip that thing over, all right? And then we'll lose control of our projectile. All right, so that's gyroscopically unstable, that it's going to be kind of spinning around, it's going to get larger and larger. So what's gyroscopically stable look like, all right? Because we're still going to have some motion that spins around. So let's say, once again, we're starting here where this red dot is, and we have a gyroscopically stable projectile, right? So maybe this is just after launch. This is kind of the thing we see. It's still spiraling around, but that spiral is going to get smaller, all right? It's going to come into a stable spin in some small little area of where it wants to be. That's the stable angle that it's going to get to. All right, so it was gyroscopic. Now let's talk about dynamic. All right, so if we are dynamically stable, let's say at some moment in time we just launched and our nose is pointing at this red dot, towards the upper left here. All right, what's going to happen if it's dynamically stable is that our aerodynamic forces are going to pull it in towards where it wants to be, okay, to that stable angle of repose, right, our yaw of repose, and then it's just going to sit there, right? So the stability is going to pull it back to where it wants to be and keep it there, right? And then it won't move anymore. All right, now let's consider dynamically unstable. All right, so we have another scenario where we just launched. The nose of our projectile is pointing to the upper left here at this where the red dot is now is where our nose is pointing versus our velocity. So if we are dynamically unstable, let's see what happens. All right, it's going to zip off in some direction. Okay, in this case, it was that one. It could easily be off to the right or down to the left or something like that. Those are all possible, but it's just going to go out. All right, and then we're going to tumble and lose control of our projectile. All right, now I want you to stop, maybe pause the video for a second and think to yourself, all right, what if we're gyroscopically stable and dynamically unstable? What is that going to look like? See if you can, predict or think about what that's going to be. All right, so let's just say that we launched with a gyroscopically stable, dynamically unstable projectile, and it comes out nose first. We're just starting with the nose pointing aligned with our velocity vector. What is going to happen to it? Okay, so gyroscopically stable is going to cause spinning that gets smaller. Dynamically unstable makes it, just kind of veer out to the side somewhere. So we get something like this. All right, So that gyroscopic stability, the spinning is getting smaller, but we're just deviating further and further away because of the dynamic instability, okay? And through that, there's kind of this yellow line here just showing you that dynamic instability there, right? And you can see how the spirals from the gyroscopic are getting smaller. So those two things combined are gonna drive it like this, all right? And with the dynamic instability, it's eventually gonna lose control and tumble on us. All right, so that's the end of this video. I hope those animations gave you a little bit of an idea of how some of these stabilities and instabilities work, and I will see you in class.